Now again in this direction we have to write all these vertices. So V1, V2, V4, V5, V6. Now make a matrix graph like this. Now as I already told you, if there is an end between the vertices, we have to put 1. If there is no edge between the two vertices, we have to put 0 here. Now let us take this graph. V1, 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 V1. No, there is no vertices. V1, V2, V1, V2. No, there is no vertices. V1, V4, V1, V4. Yes, there is an edge. And then V1, V5. V1 is here, V5 is here, no edge. V1, V6. V1, V6. Yes, there is an edge. V2, V1. V2, V1, there is no edge. V2, V2, there is no edge. V2, V4. V2, V4, there is no edge. V2, V5. V2, V5, yes, there is an edge. V2, V6. V2, V6, yes, there is one edge. V4, V1. V4, V1, yes, there is an edge. V4, V2. V4, V2, there is no edge. V4, V4, no edge. V4, V5. V4, V5, one edge. V4, V6. V4, V6, no edge. Now come to the fifth row. V5, V1. V5, V1, no connection, 0. V5, V2. V5, V2, yes, there is a connection, there is an edge. So 1. V5, V4. V5, V4, yes, there is an edge. V5, V5, no, there is one edge. V5, V6. V5, V6, no, there is no edge. The last one, V4, V1. V4, V1, no connection. V6, V1. V6, V1. V6, V1, yes, there is a connection here. V6, V2. V6, V2, yes, there is a connection. V6, V4. V6, then V4, no connection. V6, V5. V6, V5, no connection. And last one, V6, V6, no connection. So this way, if the graph is given to us, we can draw, if the graph is given, we can find the graph. And if a graph is given, we can find the matrices. This matrix is called adjacent matrix for P. If graph is given, we can make a matrix. This matrix is called adjoint matrix to Q, because the adjacent vertex we are taking into account here. Okay, so thank you.